center of mass. The center of mass is the point where all the mass of a given object can be considered to be concentrated. Let me try to put together the following example. Here is a random object, and I want to find out where is the center of mass of this object as measured from this reference point of measurement set up by the XY system coordinate. In order to do this, I need to break this mass into many small pieces. But in my case here, I'm only going to break it into, let's say, 7 or 8 pieces. Something that looks like this. The next thing I need to find is the distance from the origin to each and one of these masses. I only made fewer lines so my diagram doesn't get too messy. The distance from M1 to the origin is R1. The distance from M4 to the origin is R4, and the distance from M7 to the origin is R7, and you can make all the others if you want to. The mathematical formula to find the center of mass as measured from the origin is given by the following relationship. The vector R center of mass is given by the following formula. M1 times R1. Then you go to the second mass, M2 times R2. And you keep going to the next one until you complete all of them. In my case, I have 7, so it's going to have M7 R7. Divide by the sum of all the masses, M1 plus M2, and you keep adding until the last mass, which is in my case M7. This is how you figure out the center of mass as measured from some reference point of measurement, which is the origin of my system coordinate. In this two-dimensional case, what you need to do is you need to break this one into X and Y component to find the X component for the R center of mass and the Y component, etc. In a one-dimensional system, let's say I have a combination of 3 masses, M1 located at a position of +1, could be meters, it could be something else. M2 is located at a position equal -2, and M3 located at a position equal 3. That's along the x-axis. We would like to find out where is the center of mass of these 3 masses as measured from the origin, which is our 0, as if these 3 masses are connected to each other by means of massless rigid rod. Alright, the approach is similar to what I have done earlier, except it's one-dimensional. The x position of the center of mass of my system will be, like before, M1 times x1. What is x1 in this case? It's from the origin to M1, which is +1, plus M2 times x2. Let's look for x2. It's from the origin to where M2 is located. It's -2. Pay attention to this. Plus M3 times x3, which is from the origin to where M3 is located, which is +3, divide by the sum of the masses. M1 plus M2 plus M3. If you have more, you keep adding. Like that. Now, I have a question. What is the difference between the center of mass and the center of gravity? I already introduced what the center of mass is, where all the mass of a given object can be considered to be concentrated. How about now the center of gravity? We hear about that one a lot, okay? There is a slight difference. If the object is small, then there is no difference whatsoever between the center of mass and the center of gravity. But if the object is long, let's say I have a 2-mile long rod. First, I'm going to mount it horizontally. something that looks like this. If you want to pivot this long rod and keep it balanced, clearly you have to place a pivot exactly around the middle. And that's where the center of mass is. Why this rod here is balanced at the middle? The reason is the pull of gravity at any point, either you go here or any other point, it's exactly the same, and it does equal 9.8. 9.8 here, meters per second squared, 9.8. And therefore, the pull on one side is exactly the same as the pull on the opposite side, and therefore this rod will balance exactly at the center, which is the center of mass. In cases where objects are mounted horizontally, the center of mass and the center of gravity are identical. How about if we turn this same object into a vertical position? In a case like this, the center of mass will continue to be the center of the object because it is a uniform object, but notice that the pull of gravity at the bottom, it could be 9.8 here near the surface of the earth. Let me make up few points. Here maybe it's 9.0 at the center of mass, meters per second squared, because the gravity decreases with altitude, correct? Let's pick another point right here in the middle. Maybe it's 9.4 meters per second squared. If you go to another point here, maybe it is 8.6 meters per second squared, and at the top something like 8.2 meters per second squared. Now, clearly the pull of gravity on the lower part of my system is more than it is on the upper part. Again, this is the center of mass right here. The question is it possible that we're going to be able to balance this rod from the exact point, the center, which is the center of mass? The answer is there is not, because there is more pull on the lower part than it is at the upper part. Therefore, what do you expect the center of gravity to do? Is going to shift down to a point like here. This is what the center of gravity, and that will clarify for us the difference between the center of mass and the center of gravity. The center of gravity is depending upon the gravity. However, the center of mass is only depending upon the mass itself, where the entire mass of the object can be concentrated.